That's not too bad by hand. When I said use the calculator, I thought it was going to be really bad by hand, but it's not that bad. So this is x to the 1/2. And then this is x to the third. So the derivative here would be 1/2 x to the negative 1/2. Derivative here is 3x squared. A few different ways you can work this. I think it's easiest to see if we move this down to the bottom, like we talked about yesterday, and then we got the 3x squared over here. Then I can put that over 1, and then cross multiply. I think that's the way I would go about it. There's other ways to do it. If you see another way that works for you, that's cool. Then I would cross multiply, and I would get 6x to the 5/2, because you got to add up 2 and the 1/2. And then 1 times 1 is 1. And then I would divide by 6. So we'll get x to the 5/2 equals 1/6. And then do we know how to get rid of powers? Solve that. What do you get? What you doing? What is square root as an exponent? Okay. Does that help? So this was a squared, and to solve it, you raised it to 1/2. You didn't think about it that way, but that's what you did. So if that's the 5/2, how do I get rid of it? Okay, I guess I'll just tell you. Raise to the reciprocal. Because when you have power to a power, what do you do with those? You multiply, so what's going to happen? They're just going to cancel out, right? So 1/6 to the 2/5 would be your answer. But let's look at how to do it with the calculator too, because your calculator does some equations. I don't think we've done that in solver. So get your calculator out. And unlike your main screen, we're not going to graph it, we're going to have it like calculator here. So F2, yeah, F2 is solve. And again, you get the calculator on half the AB test. Half the AB test. So there are questions that this comes in very handy. Then I type in the equation like as it is. So if the derivative was 1 divided by 2x to the 0.5. That was like the left side of my equation, right? And then you literally put the equal sign. The right hand side was 3x squared. Don't hit enter yet. If you were to hit enter now, it would tell you that. I think it says like not enough. Let's see. Too few arguments. Okay, so what it wants to know is like, what variable do you want me to solve for? Which seems like a silly question. There's only one variable in there, but sometimes there's not. So you just play in there, do what it wants. So hit comma, and then x. Which should be obvious, but it's not. And then you get your solution there. So that's the same answer. If we wanted it to be a decimal, how do we do that? Diamond that. 0.488. So solve e to the x equals 12. Just make it up. E to the x equals 12. Tell me what x is. E to the x equals 12. Sig for x. F2 solve is, it's with the variable x, diamond e to the x. Put your equal sign. 6. Some of the stuff here is pretty straightforward and easy, and some of it people have trouble with. These are rules that you kind of end up not really thinking about, but you do use them. So let's just kind of talk through like a constant. So if I have y equals 8, or y equals 6, or y equals negative 100, the derivative is the slope, right? What kind of lines are all those? Don't say straight. They're all horizontal lines, right? What's the slope of any horizontal line? 0. The derivative of a constant is 0. If you want to apply the power rule to that, just to kind of show you it's the same, y equals 8, for example, couldn't I really write that as that if I wanted to? Because anything with 0 power is 1. So now apply the power rule. So bring down the 0, multiply it by the 8 that's there, and you'll get 0x, reduce the power by 1, but it doesn't matter because 0 times anything is 0. So like the power rule makes sense, kind of like what it is finding makes sense, whichever way you think about that. It's up to you. Same idea for c times u or c times. So this is like y equals 4x or y equals 12x. Remember, we're trying to find the derivative, which is the slope. So that's just in like slope-intercept form, right? What's the slope of this one? 4. What's the slope of this one? 12. So the derivative of this is weird. I don't like the u. The derivative of k times x is k. That's how I would get that. And again, if you prefer the power rule, like that y equals 4x, we know it's supposed to come out to 4 because we know the slope of that line is 4. So do your power rule. Take the one that's up there, multiply it by the number down there, reduce the power by 1, so now it's a 0. And what's anything to the 0? It's 1, so that comes out to 4 also. So again, think through what it means, or just apply the rule. That's all the same. And then this is just saying, like, I'm not even going to write it because it's more confusing than it has to be. All that means is if I have like multiple terms, you just take the derivative of 1 and then go to the next, and then go to the next. So to do an easier one than they have on there, all I'm saying is if I have y squared, y equals x squared plus x, you would take the derivative of this part and get 2x, and then you bring down the plus sign, and you take the derivative of that part and you get 1, and then you get it. It's just saying you can do like multiple. So if I were to do 1, rewrite it first. So that's 2x squared minus, I gotta write that as 5x to the negative 1. Is that right? I don't have a rule yet or a way to handle things when x is at the bottom yet, but even when I do, it kind of sucks. So I'm gonna choose this method if I can. Then I just take the derivative of all three things. That's all that rule is saying. So what's the derivative of 2x squared? 4x. Here I take the negative 1 up there, multiply by the negative 5 in front. That's a positive 5. Reduce the power by 1. And then that's a constant. So what's the derivative of a constant? 0. So we're done. So try 2. Careful, is pi a variable? It's not a variable. Pi is a constant.
I'm not quite sure how to help you with that.
Nobody asked. What did you hear? Alexa, what did you hear?
I heard, and then make sure you keep your prime straight. Did I take a derivative yet?
So don't put y prime. It's a common mistake I see because you're like, oh, I just took the derivative, so that's y prime. But you didn't, you just rewrote it. So now you're taking the derivative, so now you put your prime. So bring down the 1/2 times the 8 is 4, reduce the power by 1. Bring down the 6 times the -1/3 is -2 or -6/3 if you're not. It's from 6 divided by 3, I've done it before. Reduce the power by 1, and then that's a constant, so what's the derivative? It's just 0, so this will be your answer. Those two okay? Alright. Horizontal tangent lines. So again, just kind of applying like the concept of what we're trying to find. So I'm looking for horizontal tangents, which is basically there and there. So like where it turns around. So where it turns around, the surfboard would be horizontal. At those spots, what is true about the slope? It's 0. And I know that the derivative is the slope. So what I want to do here is take my derivative and set it equal to 0. We're doing that because the derivative tells you slope, and if the slope is 0, then we know it's horizontal. So f prime of x would be, that's not this graph, that's weird. Where'd you put that graph? This is a parabola, right? That's not. So the derivative here would be 8x plus 7. And then you would just solve. So you would get -7 over 8. So it's not this graph. You're not getting that answer. Questions there? Horizontal. Right, normal lines. Normal means perpendicular. Perpendicular slopes are negative reciprocals. So I'm going to do this just like the tangent line, except for at the very end when I do the slope. If I find the slope of the tangent line is like -1/3, the perpendicular line will be +3. So you flip it over and you change the sign. So I'm going to go through my normal process. What goes here is the x value they gave me. What goes here is plug in 3. So 27 minus 12, so 15. I believe that's 21. So I'm plugging into the original to find that. And then if I plug in the derivative, it tells me the slope of the tangent. This is the normal line, so we have to adjust it. So f prime of x is 3x squared minus 8x plus 1. And I'm going to plug 3 in there. I'm not going to write that down. So this will be 3 times 3 squared is 27. So this should be 4. You guys get 4 also? Yeah. I got 21, did I not? Oh no, 3 squared is not 4. Not at all. 27 minus the -9 is -3. Is that what you got? Thank you. Do we agree with my 4? So I get 4, but that's the slope of the tangent line. That's the slope of the circle. We're looking for completely perpendicular to the circle. So you flip the slope and you change the sign. So this 4 turns into a -1/4. And that would be the equation of the normal line. The tangent line would be the exact same except for that one number. So this is your tangent. That's your normal. Like it's identical. identical except for you flip over and change the sign for this. Questions there? Alright, piecewise. Keep grinding. So if it's going to be differentiable, this is a piecewise function. If I have that, is it possible that it could even be differentiable? So the y values have to be first one. If I have that, is it differentiable? No. So the slopes have to be the same also. So two things have to be the same. The y values and the derivatives must match. So the y values matching makes it continuous, and the derivatives matching makes it differential. So we gotta check. So I gotta plug this -1 into both, and let's first make sure that the y values match. That one. Plug -1 into the bottom. That's positive 7 minus 3. I get 4 for that. Whoa. Believe what you do. Don't tell Mr. Brown. Everything's fine. So when I plugged in, stop. I got 4 for both of the y values. That's checking that's continuous. Now I gotta check if it's differential. So I gotta check if that slope and that slope are the same. How do we find slope in this class? Derivative. So we gotta find out if those derivatives are the same. So 10x plus 3. It's like, is it equal to? I don't know. -7. Because the derivative of that bottom part is just -7. So if I plug -1 in, those are equal. So the y values were the same, derivatives were the same, so we can say yes, it's differential. Question on that? Alright, let's look at 6. I need to make the function differential. So two things have to be true. The two equations have to be equal. When x equals 3, and the two derivatives have to be equal when x equals 3. So let's start with the original equations. So x squared minus ax plus 2 is supposed to equal x plus b. But what's x? X is 3. So this is like 9 minus 3x plus 2 equals 3. I'm sorry. Yeah, 3a plus 2 equals 3 plus b. So I think I'm going to probably have an a and a b in the second one too. We'll get like a system of equations, two equations, two unknowns. So I'm going to solve this for b. So b would equal -3a. We got 11 over here right now. So if I bring that 3 over, b is going to equal -3a plus 8. And that's all I can do right now because I don't know what a is. But that's going to help me find it. So that's setting the originals equal. Now, let's set the derivatives equal. So the derivative of the top part is 2x minus a, because that's the constant in front of the x. And then the 2 here, the derivative goes away because that's just a constant. That's like, okay, is that equal to the derivative 6 minus A equals 1 plus B, which would be the same as 5 minus A equals B. Agree? Oh, yeah. Wait. No. What's Wes going to say? Where does derivative of B is 0? That was a big fail. I got so excited about two solutions, or two equations. So B is a constant. B is just some number. So what's the derivative number? 0, because that's a horizontal line. The slope is 0. That's my bad thinking. So that's just 2x minus A equals 1. So when you plug in 3, you get 6 minus A equals 1. So A will equal 5. There's A equals 5. And then I can find B, because I know over here B is just negative 3A plus 8. And now I know what A is. So I can go negative 3 times 5 plus 8, so negative 15 plus 8. So B would be negative 7. Questions on that? Sorry about that. So I want you to try to finish 2, 6. Let me see if there's any we're skipping. I imagine there'll be some questions, so please bring them. Ask them. Just skip the test prep. We might do it tomorrow, we might not. But I think this is like enough by the time. This is where some people start to get bugged out. So just don't do the test. Don't kill it, because we might do it later, but don't do the test prep for tomorrow. Thanks, you okay? No, sorry. I don't know. Caffeine makes me feel